Okay, so for these first few problems, we're going to be looking at the special right triangles that we've learned about 30, 60, 90, and 45, 45, 90. So for this one, what is the sine of 30 degrees? So let's look at this triangle. 30 degrees, sine is opposite over hypotenuse. So it would be 1 over 2. And that's going to be true for all triangles that are 30, 60, 90. Sine of 30 is always going to be 1/2. And we will learn some ways to start memorizing that. And how I know that is sine equals opposite over. All right, same question, but for the cosine of 60 degrees. This is 60 degrees, opposite would be, or sorry, cosine is adjacent over hypotenuse. So once again, we're looking at the same leg, this bottom leg, over the hypotenuse. So it's still 1/2. We're looking at the same piece that we were looking at before, so it's going to be the same answer. And this is just cosine equals adjacent over hypotenuse. Using the special right triangles, what is the cosine of 30? So we'll just keep working through it. Cosine of 30 is adjacent over hypotenuse, so square root of 3 over 2. Again, that's true for any 30-degree angle. Cosine equals adjacent over hypotenuse. Let's see, what is the sine of 60 degrees? Well, so if, just like we saw before, it's going to be the same thing because it's going to be opposite of 60, which is the same square root of 3 leg over hypotenuse. Over 2. So root 3 over 2. Sine equals opposite over let's see, now let's look at the 45-degree ones. What is the sine of 45 degrees? We can pick either angle. Sine is opposite over hypotenuse, so root 2 over 2. And also 1 over root 2 is the same thing, but we're going to start learning how to rationalize the denominator, which means turning the denominator into a rational number, which excludes square roots and cubed roots and roots of all sizes. So sine of 45 is root 2 over 2. In fact, that means the cosine of 45 is also root 2 over 2. So those are going to be the same. So root 2 over 2, sine equals opposite over hypotenuse. And then cosine of 45, we just said that's the same thing. Cosine equals adjacent over hypotenuse. Let's see, what is the tangent of 45 degrees? So tangent is going to be opposite over adjacent, right? So root 2 over root 2, well, that's just going to be 1. What is the tangent of 30 degrees? So looking back at this triangle, opposite over adjacent is going to be 1 over root 3. Another way to write that would be to rationalize the denominator. You'd multiply both the top and the bottom by the square root of 3, and you'd get root 3 over 3. But I didn't put that as an option. So it's 1 over root 3. Again, tangent equals and then the last one was the tangent of 60. It's going to be the inverse, or the reciprocal of that, right? So tangent of 60 is going to be opposite over adjacent, square root of 3 over 1, which is just the square root of 3. All right, now we're going to start doing some triangles. So right triangle shown, what is the length of side AB? So we're trying to find this length, and we have this one. Well, to me, that looks like we have one of the legs, and we're trying to find the other leg. We don't know anything about the hypotenuse, which means we're going to be using tangent here. Because tangent is the one that's opposite over adjacent. It uses both legs. It doesn't use the hypotenuse. So let's see. We've got triangle ABC right here, and we're trying to find AB. Well, again, so we're going to use the tangent of 35 degrees. Tangent is opposite over adjacent, so it's going to be AB over 12. So then to get AB by itself, I'm just going to multiply both sides by 12. Those cancel. So then 12 times tangent of 35, we can just plug that into a calculator. And we always want to make sure that we're in degrees. So this is going to be, this is in degrees, so this is 8.4. All right, let's look at the next one. Let's see, what is the value of y? So what I'm looking at here is we're looking at the side that is adjacent to the angle. It's part of the angle, so it's adjacent. And we have the hypotenuse. So then we're just going to be looking at cosine because it's opposite, or it's adjacent over hypotenuse. So we're going to take cosine of 38 degrees, and we're going to say that's equal to adjacent over hypotenuse, so y over 12. Well, then this is a very similar one. We can just multiply both sides by the hypotenuse. These cancel, and then we've got 12 cosine of 38. So looking back at our calculator, we're going to put 12 cosine 38, and that's going to be 9.5 about. All right, so this one, let's see, we've got 12 degrees, we've got the opposite side, and then we're missing the hypotenuse, and we're trying to find that. So we've got opposite and hypotenuse that we're working with, so that means sine, right? Sine is opposite over hypotenuse. So let's write an equation for that one. Okay, so we've got 12 degrees, so we're going to say the sine of 12 degrees equals 500 meters over h. So now we need to solve for h. This is a little different because we're going to have to get h by itself a different way. So we're going to multiply both sides by h. Those cancel. And now you have h sine of 12 degrees equals 500 meters. And then just to get h by itself, we're going to divide both sides by sine of 12 degrees. And then these two cancel, so then you have h equals 500 meters divided by sine of 12 degrees. 500 divided by sine of 12. And we're still in degrees, so that's going to be 2404.9. Don't forget our units, meters. Two more, let's see, all right. Find the length of AC, so this is one where we're given the length that is adjacent to the angle, and we're trying to find the length that is opposite the angle. So if we have adjacent and we're looking for opposite, then it's going to be tangent, right? Because those are the two that make up tangent. So let's see. All right, so we've got tangent of 27 degrees equals opposite is AC divided by the adjacent, which is 13 centimeters. So then this is similar to a couple of the other ones we did in the solving process, in that all we have to do is multiply both sides by 13 centimeters. And these cancel, and then we've got AC equals 13 centimeters times the tangent of 27. So we got 13 times tangent 27 equals 6.6 centimeters. And our last one, we got to find h and x. So we can find h first, I guess. It's on top. We're going to try to find the hypotenuse, and we know the opposite. It wouldn't do us much good to use the adjacent, because then we'd end up with x over h, and that's not going to help us, right? That's two variables. But if we do the opposite one, we can say, well, the sine of 51 is 10 over h, because that's opposite. And then we can solve for h. So we have the sine of 51 equals 10 over h. Once again, we're going to have to do that solution where we take two steps to get h on top by itself. Actually, I'm going to show you a different way to do these in case you want to maybe pick your poison. So we can take the reciprocal of both sides, and that'll move h up to the top and 10 down to the bottom. And then we do that on this side, and since this is the same as sine over 1, then we would just flip both sides, right? So now we're going to have 1 over the sine of 51 degrees equals h over 10. So I just flipped both of them. And in doing that, I made h a little more accessible. So now I can multiply both sides by 10. These cancel, and I have 10 divided by the sine of 51 degrees, basically. So let's see. 10 over sine 51, that equals 12.9. And this one, let's see, x is going to be, we're going to have to do a new equation for that, so let's go back. So, like I said earlier, x is on the adjacent side of this triangle, so we could just set it up and say, well, cosine of 51 equals x over h, because we now know h. Another thing we could do is, since this is a right triangle, we'd use the Pythagorean theorem and say, well, 12.9 squared equals 10 squared plus x squared, and then solve for x that way. But that seems like a little more work. I'm going to do the cosine, or actually I'm going to do tangent because we already have the 10, and 10's easier to work with than 12.9. So I'm going to say tangent (51 degrees) equals opposite over adjacent, so 10 over x. And then I'm just going to flip again like I did on the last one. So I'm going to say 1 over the tangent of 51 equals x over 10. And then I can just multiply both sides by 10. These cancel out. So x equals 10 over tangent 51. So we've got 10 divided by tangent of 51. That equals 8.1 about. And it's good.